Welcome to DuPont here at IPC Apex Expo. I'm delighted to be joined by Anthony Reardon. Good to see you, Anthony. Thank you for joining us today.
Yeah, thank you for having me.
Okay.
It's my pleasure.
We're going to look at maybe 4 different products here today. We're going to start off maybe with this inner layer that's sitting here in front of us.
Yeah.
Maybe you can explain some of the properties in this inner layer and its functionality.
Absolutely, yeah. So what we have here is our Interra HK04 product, and this is really something that is actually perfect for your readers when we talk about surface mount technology, because this is taking the embedded capacitor or the capacitance off of the surface and embedding them into the actual board. So for your ground and power planes, you've got this very thin, very durable material. It's based on our polyimide, our very famous polyimides that's used throughout all of our Pyralux products.
Yeah.
But the benefit is it's not like the competitive material, which is epoxy. And when you're curing the epoxy, it gets very brittle. It's almost like a potato chip, and it falls apart.
Okay.
And this, you can see, it's not cracking. You can move it.
It's very flexible.
Yeah. It's quite easy to process and handle, as opposed to the epoxy-based systems that are out there right now.
Excellent. Okay, so the second item we're going to look at here is, you mentioned polyimide, is this one over here. So tell us, this is one that where you can embed some thermal properties, I believe.
Yeah.
Take it away.
Sure. So this is our Pyralux ML. It's really taking, again, when you look at our Pyralux portfolio and our high reliability polyimides that have been, well, particularly on Mars for over 20 years now, and they're still working, we've taken that technology and applied resistive alloys to it. So our industry standard has always been either a single-sided copper or a double-sided copper clad with polyimide in the middle.
Yeah.
Now what we've done is we've got copper on one side and a resistive material on the top, so you can make any kind of heater, whatever your specifications are. Right. And this is just a sample that shows you that you can make even different degrees of each one of these sections. This is just a 24-volt piece here, and each section is going to have a different 5 degrees difference. This is actually room temperature. This is 5, 10, 20, and I think this is like 30 or something like that. So you can actually design that in.
Right.
So you can imagine things in space that you need your electronics heated. You need to keep moisture out of things. You can do it that way. You hear about the electrical cars that don't start. So these are the things that would really help you in that situation.
So it seems that it's got a wide range of applications, and
absolutely
you could do, and you could put different types of alloys on one side, etc.
And just to be clear, I mean, this is, fabricators make this right now, but they wanted to take all of those steps out of their fabrication process so they can speed up time to market, right? Yep. And so what they did is they've come to us and say, can you please make, your Pyralux brand, but put an alloy on it, something other than copper. And so we listened to them, and we're coming out with this now. Okay. So,
Now, silver is one of the most conductive materials in that we use in electronics.
Yes.
We've got 2 samples here.
Yes.
Now, I'll hold them up for the camera, and I'm not sure if we're going to be able to see it, but there's one of them here is obviously got a fairly deep defect in the middle of it there.
It's gouge, yes.
Gouge, basically. And the other material is treated with a proprietary pixie dust, but basically it's given the same gouge, but you can see it's not made half the indentation that the other one has. So tell us a little bit about this system, and what is it called, first of all?
Sure, so this is Silveron GT210. Okay. It's actually part of a suite of materials. There's 2. There's Silveron GT210 and then the Silveron GT820. The 210 is what we're looking at here, and essentially what this is high durable silver.
Right.
The issue that you have is these connectors here. The connectors for your EV vehicles, all of those are coated with silver, because that's when you talk about conductivity, that's 100 out of 100 on that scale.
Right.
I think copper's like 87, and then gold is, or 97, gold is 84 or something like that. Right. I'm going to get these mixed up, but at the end of the day, silver's the material
the
used,
highest conductivity.
but it's soft.
Right.
And so what happens is these guys are only good for about 100 insertions. The silver, 100 insertions, and then you start getting, that's why your phones won't charge as fast or as quick. Right?
I wondered, thank you for telling me that.
Yeah, so you'll have that issue. And then so you can imagine that on an EV vehicle too, now that we're really jumping into that market. All those insertions going in and out, and after 100 cycles, you're starting to really rub that silver down.
Yeah.
With Silveron GT10, it's a high durability, and we've tested up to 10,000 cycles and see very little change. And that's what this I think is just 100 cycles, but essentially what we do is we take a ball bearing apply a little bit of pressure and just run it
back,
let it go in the lab. It makes a little bit of noise.
Yeah, I bet it does.
For the folks in the lab, but but at the end of the day, you get the results that you see here, which is very little defect and a significant gouge here on the regular silver.
Right.
So,
okay. Last item we're going to look at here is this little fella here. Is a flexible material.
Yes.
What are the specific properties and benefits of this?
So this guy here is TFAH. It's basically a rolled copper clad. Similar to our flagship products, the Pyralux AP materials.
Yeah.
This is commercially available in Asia. I'm making it commercially available here in the U.S. And the reason why we're really excited about this one is two things. One, when you're talking about high speed or 5G markets and you're going in there, a lot of folks are using LCP. Liquid crystal polymers. Yeah. That's very difficult to process. There's a lot of yield issues with it. This is going to give you the process ease of our Pyralux brand. Right. It's also going to give you the durability and the reliability of our Pyralux brand.
Right.
It also, as you can see here, I'm not sure if in the camera if you can focus in on that, but this is something that we did with a actual laser within our facility. Okay. So it's very fast processing.
So you laser etched it.
So you can laser etch your design in there. Okay. And we have a facility in Silicon Valley, up in Sunnyvale, and we have full prototyping. We've got a lot of subject matter experts there to work and help with your design. So the customer can come in, give us the design, and we can etch it in within minutes and come out with an actual working flexible circuit for them.
Excellent. Yeah. Well, that's a range of very innovative and flexible materials you've just shown us, Anthony. So I want to thank you for sharing that with us today.
Yeah, thank you. Appreciate it.